Hello, my name is Steve Eversole, and I'm going to show you my first screencast. And for my screencast, I've chosen a presentation, a PowerPoint that I use in conjunction with a variety of other methods to teach a little bit about solutions and precipitation chemistry in my high school chemistry class. And so we'll get started here with thinking inside the test tube. A little bit of background. My students at this point have learned their solubility rules and are able to, in theory anyway, are mostly able to identify whether substances are soluble in water or not. And these are the rules. They don't need to memorize them. They just need to know how to utilize the sheet that I give that has these rules on it. And so on with today's lesson. We see a test tube here with just a little bit of sodium chloride, a little lump of that in the bottom, a common component in table salt. And I talk about dissolving and ask them, well, what do you think actually happens when it dissolves? And I ask about specifically on the molecular level, and I even have them do some sketches about what they think is really happening there. To investigate this further, we play a little game we call Blinky No Blinky with a conductivity probe. And this conductivity probe blinks when the solution is a conducting solution and will not when it doesn't. And so I try a variety of things as actual demonstrations. I use demonstrations in conjunction with this PowerPoint. There's no way of getting around the effectiveness of actually doing wet chemistry, those demonstrations in conjunction with this. It draws a lot more interest, changes things up a bit. I like it, and I think the students prefer we mix it up a little bit like that too. And so we go through a variety of solutions, and I kind of help coach them through the idea that things that conduct electricity apparently must have ions, and that when ionic substances break apart, it's the ions that help conduct that electricity. A little animation here we have of a salt crystal being dropped into the water, and we can see that it separates to its ions quite quickly here. Moving on to an animation that some of my students have done with PowerPoint here. This is a silver nitrate and potassium chloride. And so I say, what if I take a crystal of these guys and drop them into some water in a beaker here? And I ask my students what they anticipate is going to happen. Hopefully, using their solubility rules, they will be able to predict that they dissociate and they break into their ions. And so after a couple minutes of usually think, pair, share, this is what we see. And for many of them, that's not much of a surprise, but I ask them, what do you suppose will happen, if anything else? What do you suppose is going to happen here? So again, another moment, time out for a think, pair, share activity, about 5 minutes or so. And I ask them to justify if they think something's going to happen, what, and if not, explain yourself. Going back to the animation here, we take a look at the ions in solution, and sure enough, we find out that the silver ions and the chloride ions combine to make an ionic compound, silver chloride. Now, a number of the students have anticipated this based on their solubility rules and knowing what they have, or what we've already discussed in class about opposites attract and the natural Coulombic forces, electrostatics there, a little bit of that. And of course, I do the demonstration in front of class, but I like to have this slide up there so I can point out some particulars. And so after the salt solution here has some silver nitrate, you can see I'm pointing right now to the pipette with silver nitrate solution in there, and when that drops through, we can see that this is a chemical reaction. This seems to be forming some sort of new substance. Another picture, I like that one neat as well. And so we talk a little bit about this. Based on our observations, we determine that this is an insoluble compound right here. And a little bit of vocabulary. At this point, it's appropriate for us to throw out a new term, which is precipitate, a chemical term that we use for that insoluble compound. And that these two terms are really synonymous in this situation here. Again, a little bit of think, pair, share to go beyond. What do you think this compound is made of? And if there's something else in there, well, then where is it? Where's that stuff in here? So a few minutes, we come back, go through some answers here. Again, using our solubility rules, we can determine that it's the AgCl. That's an insoluble compound. And that the other stuff that's around, we'll discuss more of that a little bit later, is in solution, is in that clear liquid there. So in this precipitation, how is it that we really know that silver chloride is the precipitate for those groups that maybe didn't quite figure that one out? We check our solubility rules page. And when we look at the different combinations of ions that could get together, the silver and the chloride, we see that rule number 3 says that these are mostly soluble, except, and we see that silver right here is an exception to that. Why not potassium nitrate as well? Again, if we look at our solubility rules, we see that neither the alkali salts and potassium being an alkali metal makes potassium nitrate an alkali salt, and therefore it is not soluble. I beg your pardon. It is soluble, and it will not come together to form that compound. Those ions will just remain floating around in there in solution. And we will continue to watch our animation here, which is a molecular level again of what we're seeing happening as the precipitate in the test tube I use in the demonstration. That precipitate falls to the very bottom, but the potassium and nitrate don't combine. And this is just kind of a summary right here. In the beginning, the sodium chloride crystals break apart. Some of their ions are dissolved in the solution, and then the silver nitrate is added. Notice they are in ion form right here, are added, and it gives the opportunity for the chloride ions and the silver ions to combine to make that insoluble silver chloride. One last term here, that these precipitation reactions are a type of what we call a double replacement reaction. And this leads us into writing molecular equations and ionic and net ionic equations, things of that variety. So I hope that you have been able to get something useful from this for your classroom, perhaps. And if you like, I'll be glad to share this PowerPoint with you if you send me a message. And if you make it better, I hope you get to share that with others as well. And this ends my screencast.